Let's dive straight into a major infrastructure upgrade for your AI applications, Claude's web search tool. If you're building with Claude, you already know its capabilities, but getting it seamlessly connected to the live internet has historically been a massive headache. Well, that completely changes today. Think about this for a second. Does your AI app go completely stale the literal minute it ships? It's a huge pain point for developers. Because models have a hard training data cutoff date, the second a user asks about yesterday's earnings report, a sudden regulatory update, or breaking code changes, you're usually stuck serving up outdated information, or worse, hallucinated answers. Your users expect today's facts, but your model is trapped in the past. Historically, we've tried to fix this by slapping together massive, brittle web scraping pipelines on our own servers or writing frantic prompt engineering. But this tool changes the paradigm. The solution is to fix staleness at the infrastructure level. The web search tool solves this freshness constraint natively on the server side, which means you get to bypass complex client-side scraping pipelines entirely.
So here's the actual architectural blueprint for how this works. Step 1, you just drop a single entry into your JSON request tools array. Step 2, Claude decides when a search is needed, and Anthropic servers actually execute the query, fetch the pages, and run a dynamic filter. Then, step 3, you get back a perfectly synthesized response, complete with cited URLs. The best part? All of this happens in one single API turn. You never have to handle the intermediate round trips yourself.
The secret weapon here is the February 2026 version upgrade. By explicitly specifying web_search_2026-0209 alongside supported models like Opus 4.7 or Sonnet 4.6, you're activating server-side dynamic filtering. Instead of dumping a giant, noisy HTML page into your context window, Claude writes and executes server-side code on the fly to strip the HTML down to just the highly relevant content. This drastically cuts your token costs and boosts accuracy. Let's look at one specific example to really see this in action. Imagine you're building a consumer app and a user wants to find ramen spots that opened in the last year in Austin, Texas. A standard model, it's probably going to hallucinate some generic, outdated list. But the web search tool bypasses that trap entirely. It actually fetches fresh, localized reviews of newly opened spots and provides precise, verified source citations for every single claim it makes.
3 fields really do the heavy lifting to make that happen so smoothly. First, user location automatically weights the results geographically, so a search for near me resolves perfectly to Austin without custom geocoding. Then you have max uses, which sets a strict ceiling so one chatty query doesn't accidentally burn through your budget. And finally, the allowed and blocked domains give you absolute control over the quality of your incoming sources.
Now let's talk about the key stat for this whole architecture: $10. Let that sink in for a second. $10 is your entire cost for 1,000 searches. That gives Claude live access to the public web with absolutely zero search API keys to manage, zero scraping infrastructure to maintain, and no client-side round trips. It's built on top of standard token costs, but here's a massive bonus. The returned citation fields are completely exempt from token billing. When comparing architectures, you need to pick the right tool for the job. Use this web search tool for frictionless live public web discovery. But if you need a highly specific search provider or custom ranking logic, you'll still want to stick to a custom search API. And if your data is internal and non-public, well, that's when you build out a RAG system with a vector database. So what is the ultimate key takeaway for production? This feature literally collapses massive, complex scraping and HTML parsing pipelines into a single line of code in your tools array, making it incredibly viable for batch workloads. Just remember to set max uses for strict cost control. Always use that 2026 version for dynamic filtering, and this is a critical rule from Anthropic's usage policies. You absolutely must render those citation fields for your end users. They deserve to verify the facts. To truly master this implementation, including fully worked code examples and common pitfalls to avoid, check out the Claude Master ebook at claudemaster.net. Think about it. In a world where AI models are rapidly commoditizing, real-time ground truth is basically your only competitive mode. Are you going to keep serving your users yesterday's news, or are you ready to finally plug them into the live internet? Dive into the book and find out.